And welcome to section 6.4. I'm Gregory Carlson. At the beginning of chapter 6, I gave you this table, so let's go ahead and review it one more time. You see the similarities now between the ellipse and the hyperbola. Really, it's just the difference between that plus and the minus. They use F here instead of C, but remember that these are the formulas. You'll also need to remember the formulas for eccentricity, which is the square root of 1 plus b squared over a squared, or 1 minus b squared over a squared. 1 minus for an ellipse, 1 plus for a hyperbola. So just try to keep, and then of course the circle. So just try to keep those general formulas in mind. And because what section 6.4 is about is, can we identify them based on what we have? So let's just go through them. So what do you see right here? Again, remember, you should have this kind of handy, or you should just try to do it from memory. So if I have x squared plus y squared equals 25, to me that just screams a circle, because it's x squared and y squared. It could be an ellipse, but because these are both over 1 and I have my number here, I know that the square root of this number is the radius, which is going to be a radius of 5. So this one right here is a circle. It just is. How about this one? X squared minus y squared equals 1. Well, we've got a 1 here, so it's probably an ellipse or a hyperbola. And we've got a minus right here, so that tells me hyperbola. In fact, why don't you actually try to do all of these maybe on your own and then see if my answer matches yours. Taking a look at this next one, we have 3 squared plus 8y squared with an x squared equals 24. So I can tell what the answer is by looking at it, but one thing you should think about doing is dividing everything by 24 first, because that gives us the 1 on the right. And then 3 and 24 cancel, so you get x squared over 8 plus 8 and 24 cancel, y squared over 3. And you can see there, now that equals 1, we see that that's an ellipse. Okay, so that's an ellipse. X and y are both being squared, and we have the plus. Remember, if these two numbers are the same, you can multiply the whole thing by those two numbers, and then it becomes a circle equation. So watch out, if they present it like this and these two are the same, it's actually a circle. How about this one? X equals y squared minus 8. I see that only one of the two terms are being squared, so that means it's a parabola. In fact, it's a parabola, its y is being squared, so it's a parabola that's going to open up to the left or the right. In fact, since y is positive, that tells us it's a parabola that's opening up to the positive end, or opening to the right. How about this one? 5x squared plus 5y squared equals 1. You might be tempted to say circle here, or you might be tempted to say ellipse. So it's kind of hard to tell just by looking at it, but remember, we can't have numbers here with x and y if we're doing an ellipse. They've got to be divided by something. So let's divide everything by 5. And that means you get x squared plus y squared equals a fifth, because these two cancel. And in fact, this is a circle. And the radius of this is the square root of 1 over 5. So that would be the radius of the circle, 0.2, and then take the square root of that. So that one is kind of tricky. Just remember, we can't have numbers multiplying by x squared and y squared, so you should go ahead and go straight to dividing. I could see how you might say an ellipse because it equals 1. But again, you can't have numbers multiplying. You've got to be dividing to have an ellipse. What about this one? Can you tell what this one is? Hopefully you said parabola, because that would be correct. In fact, it's a parabola that would open down, I think, because the x squared is negative. What about this one? So we can tell on this one that, let's see, what we should do here is go ahead and add the y squared over 25 over, because that would get us 1 by itself. So it would be x squared over 16 plus y squared over 25 equals 1. And now you can see right away, sorry if you've seen the screen, x squared over 16 plus y squared over 25 equals 1. You can see that that's an ellipse, actually. So the answer to that one is ellipse. So Don't think it's a hyperbola just because you see that minus sign and you think, oh, it must be a hyperbola. Remember, we need the 1 to be by itself. So move this over, and then you can see that it's actually an ellipse because it turns to a plus when you move it over. Same thing over here. You know, we need 1 by itself. So let's subtract x squared over 36. Subtract x squared over 36. And that, when we do that, is going to equal 1 minus y squared over 49 minus x squared over 36. And you can see that that right there is the graph of a hyperbola because of the minus. So this one would be a hyperbola. What about this one? X squared plus y equals 18x minus 6. Again, don't get thrown off that we have an extra x. I can still tell that this will be a parabola because only one of the two are being squared. And this 18x just means we're going to have to complete the square to figure out where the center is. So don't get worried about that. Let's look at these last two. I have 5 times all of this being squared plus 2 times all of this being squared equals 0. That's strange. It equals 0, and there's no way we're going to make it not be a 0. There's no like minus 1 that we can just add over simply. So if this is the case, remember that this is always going to be positive and this is always going to be positive. There's actually only one point that's going to make this equation true. So therefore, this is actually the graph of a point, or if you want, a circle with radius 0. And can you actually see what that point would be? If you plug in 3 here, you get 3 minus 3 is 0, 0 squared is 0, times 5 is 0. So 3 comma negative 1, because negative 1 plus 1 is 0, 0 squared is 0, times 2 is 0. So that's the only solution to this equation is 3, negative 1. What about this one over here? We've got, that makes this a point as a result. What about this one? We've got something squared over 36 plus something squared over 49 equals negative 1. So let's think about this. If it was positive 1, it would be an ellipse. But it says negative 1 right there. Now, x squared is always going to be positive. Y squared is always going to be positive, or 0. So the smallest I can make these is if they're both 0, in which case I have 0 plus 0 equals 0, which is not equal to negative 1. So, and even if I plug in negatives, when I square them, they just turn positive. So I've got 0 or a positive plus 0 or a positive. There's no way to make that equal negative 1. So this one is actually no graph, or you could say no solutions. There might be a complex solution where we plug in I or something, but there's no real solutions that are going to satisfy this equation. So hopefully all of that makes sense, just a process of elimination to figure out which ones of these are graphs. In the final two examples for section 6.4, you can see we did something like this already when we were graphing circles, I think way back in chapter 2 or chapter 3. And so let's go ahead and do these two examples in the next video, and then we'll be done with 6.4. So I will see you in part 2.